Hello, Bob here. Going to do another demo on the dipole of matter material. What I have set up here on this November 8th of 2011 is I'm still using a closed chamber, and what I have in here is I made up a pivoting strip. This happens to be plastic. It's actually a coffee can lid plastic. It's a low grade plastic. It has a fairly good, at least a number 2 value dielectric. And I've got it on set in the center of the shaft best I could. You got the upper and lower plate. They're full plates, top and bottom. Bottom being negative. And this happens to be a steel one that I made, and it works, but I'm not going to use it in this demo. But I made it. It's kind of a complicated cutout setup, but I needed to get it as close to balance as I could to show you, get the dipole effect and the attraction. As you can see, this is about as close to center as I can get it. Now I'm going to turn it. You see, there it is. It's pulling up. It has dipole, and you get charges build up on it, and it pulls it down, and then it'll release. It'll stay there as long as I'm cranking, and it'll still stay in that position until I discharge it, until it's fully discharged. It'll slowly come back on its own as the machine dissipates. But you can see if it touches the plate, it discharges immediately, and you see it jump. There, it's just holding it. Now that is a fairly good dielectric. Now, it's going to be a rather long. Now we're going to try other material. Now this, remember, this was plastic. Here we have the same identical parts set up the same way, and now it's paper. This one, it looks the same physically, but it's made out of paper. Now we're going to hook that up. It doesn't take much, just to lay it over the positive, negative rods going up to the terminals, discharge terminals. See how quickly that goes up, stays up. So there again, you got full plate, top and bottom. I can't get this one to balance quite as good. I wish it was better. I don't know. It's kind of tricky. I wish there was a better system, but apparently I got things activated enough that it's not fully discharging. As you can see, it pulls it down, and that's paper. Right? You see how much faster that activated than the plastic? Much quicker in its response. More like a conductor than a, well, it is conducting, but you think of conductors as being metal, which is a good rule. Now this is metal. This is aluminum I have in this setup. It's in an open chamber, and it doesn't matter whether you use an open chamber or a closed one. Sorry about the delay. Getting it hooked up. There. Now, being open chamber, there's enough breeze. Like I said, it's been a very warm day. I got all the windows open. See how quick that responds? And all of them will do exactly what they'll stay there. Now you say, well, how can that be dipole? Well, it has to be dipolar. There's enough residual. You've actually got a positive. This is negative. This is positive. And the machine is not running, but it's holding. That's the electrical field. It's not the ions moving. It's the electrical field. And there it is. And I discharge the electrical field, and it goes right back to neutral. But the thing, you can try different material. You can come up with a better setup than this. You just need your test material. It's just how you set it up, make it. This is for the equipment I had. My little chambers, I made them. They are just flat, and then I cut them out, and I made a little metal bracket to hold them on the center column. And I can move that up and down, so I can try to get it right in the center. It doesn't have to be, but you can tell. You see how quickly that responds? And there's no magnetism here because of the simple fact it's not steel. Now this one is steel. Just stay there until I discharge the machine. There. I just wanted to show you that. You can come up with it's a neat thing. You can try different materials that you can fashion yourself, but it shows you the dipole effect. The electric field generates. Remember, opposites attract. And like charges repel. You got a negative bottom and a positive top. So that means that the material has the dipole in order to be attracted to both. If it didn't dipole, it wouldn't move. That's all there is to it. There would be no charge. But it's more of an electric field effect than it is an ion. The electric field force that's doing this. It's your greatest cause. You keep cranking, and of course you're going to generate more ions. All right. I hope you find that interesting, and try to duplicate one, or build one yourself. If you got a Volta hailstorm chamber, you can make one of these. It's kind of interesting. Try different material. See what the higher the dielectric, the slower it will pull up. But once you get the dielectric one charged, it won't discharge very rapidly. It won't. It'll stay dipole longer, and it won't. It'll respond quicker after use. You've got to let it totally relax, or lose what they call relieve all the dielectric stress. And certain materials, once they're kicked over, like plastics, they have a tendency to stay there. All right, you're on your own now. So I hope they'll help you understand that this is the basic mechanism for all electrical activity, period. And it's all done with the electrons. Electrons don't move, we wouldn't have electricity. It's just that simple. All right. I hope you have anything to say, a question, just give me a comment or leave me a message on the channel. Talk to you later.